Okay, well, this is my version of a Prezi with Screencast-O-Matic. It's been an eventful few days, to say the least. I appreciate it letting me get this in a little bit late. So, I'm Daniel Cluff, and this is my opportunity to teach 7th grade science with the use of Screencast-O-Matic and a Prezi. It's been fun. So, in teaching science, the main standard that I'll be covering on here is that students will understand the structure of matter. Our objective is to describe the structures of matter. And very fun part of life, if you think about it, of a school of fish here, every little thing can play part of the bigger group. And so a lot of us can see the universe. We see the sun, the moon, the stars, and we go, wow, that's huge. Well, yeah, onto our scale it is. But the universe and the galaxies within it are forever. And so, if we took that scale down to our own life and what we see and what we can touch, not just what we dream about out in space, we can really start to understand that that universe goes so many directions, not just big, it goes teeny tiny. So, if you think about it, within the universe that we know of, we have sun, moon, stars, three main things. Let's just stick with that. Within atoms, it's not much different. For us, the main thing, atoms, is what make up the small part of life. And I'm going to go back to that. Atoms is all the matter in this world is made of something. You cannot see it, and all of them have different energies. And so, to explain this a little bit better, I have this really awesome presentation, and I want you guys to watch this on your own time because it explains it in good detail, but it's like a 10-minute YouTube. And after you watch it, it'll make more sense. But here's the basic thing. Because each particle has a different amount of energy, it does something differently. Just like the sun does something differently than the moon. One shines, one rotates. Both of them do something to make the universe work. So here's the basic thing we're going to introduce. Electrons are negatively charged. So they have an energy that's different than what's called a proton. They're positively charged. So if you work with magnets, think of the electrons as the things that are really strong and powerful. And protons are powerful too, but they're not as excitable. They're bigger. And electrons are these little teeny things that just move all over the place. And the neutrons just kind of act as the glue between the two of them, or a neutral energy. So kind of a cool way to think about it. Now, in matter, we have this really interesting thing. Anything you pick up, for example, my shirt, has something. It's a matter of how dense it is, and it has a mass to it, and it has a volume. So, density is like how close things are put together. So, the closer they are, the more dense they are. The mass is just everything there. So, I could take a styrofoam block that's 2 feet by 2 feet and a steel block that's 2 feet by 2 feet. Two of them, they're going to have considerably the same amount of volume because they fill that same space, but their mass and their density are completely different. If I drop the styrofoam on your head, we're okay. If I drop the block of metal on you, I'm pretty sure I'd be in trouble. And so these three things make up all things that we see: density, mass, and volume. So density is really what mass is divided by its volume. It makes sense as you go. Now, density is really cool because it can change. You take water, for example. Water changes with energy. Think of it this way. Uh, you take a cup of water and you place it outside in the St. George heat, and what's going to happen to it? In time, it's going to disappear. It's going to turn into water vapor or gas. It goes away. Now, if you take that same cup of water and you stick it up in the North Pole and leave it outside, it's going to freeze. And because those things change, it's just how packed those water molecules are next to each other. When it's solid, those water molecules are really slow. They don't move very much, and they stick together. Let's call it stick together. And so, because there's less space in everything, there is more density. Now, as that when a block of ice starts to get more heat, those bonds start to come apart, and the molecules can now move around a little bit. So now it's less dense because obviously it's not solid and it weighs less, for example. So there's a space in between them. Now, if you took all of that water and you added more energy to it, it comes out and becomes a gas. You can play around with it, but it's all over the place. It's moving really fast. And so density changes with energy also. And so that's the main important thing to know about the subjective. This is my reference here. I went and read the density functional exchange of energy approximation with correct asymptotic behavior. It basically talks about the properties of energy and how mass and volume really explain what density is. So there's my introduction, and I hope it was awesome.